Investigation of Curves, Section 2, Derivatives of Curves. Video 3, Gradients of Tangents to Polar Curves. The gradient of a tangent in polar coordinates is given by the following formula. dy by dx equals dr by d theta sine theta plus r cos theta all over dr by d theta cos theta minus r sine theta. Now there's a common mistake that people make when working with tangents and polar coordinates, which is to write down dr by d theta and then use that as if it were the gradient of the tangent. Because it's an easy mistake to make. You think to yourself, well, I would have dy by dx if I had coordinates y and x, so dr by d theta because I've got coordinates r and theta. The problem is this dr by d theta is not telling us how y is changing with x, which is what the gradient is all about. It's telling us how r is changing with theta. So in order to work out the gradient of the tangent, I need to use this formula, and I need to not be tempted to just write down dr by d theta on its own. So let's have a look at where this formula comes from. Well, it's very similar to what we did with parametric equations. So when we wanted to work out dy by dx and we knew x and y in terms of t, we worked out dx by dt, dy by dt, and then divided one by the other. And I'm doing exactly the same thing here, using x equals r cos theta and y equals r sine theta. So first of all, I work out dx by d theta, and using my product rule, I get dr by d theta multiplied by cos theta, and then I get r multiplied by minus sine theta, giving me this expression here. And then for the second one, dy by d theta, I get dr by d theta times sine theta plus r times cos theta. And then to work out dy by dx, I just have to do this one divided by this one. So dr by d theta sine theta plus r cos theta all over dr by d theta cos theta minus r sine theta. Let's have a look at an example. So find an expression for the gradient of the tangent to the curve with polar equation r equals sine 2 theta plus 1. Well, the first thing I'm going to do is to plot this, because it's always good to see the shape of the curve that I'm working with and see if I can get any useful insights. So r equals sine theta, sine 2 theta plus 1. Just zoom in on that a little bit. So I've got these two loops coming around like that. So let's have a go at working out the derivative, and then we will be in a position where we can analyse some of those things. I'm going to start off by putting the expression that I've got for r. So r was equal to sine of 2 theta plus 1. So I've now got an expression for r there. Now the next thing that I wanted to work out was dr by d theta. So I want the derivative of my expression 1, so $1, and I want that with respect to theta. So that gives me 2 cos 2 theta. Now I'm going to put this together to make my formula for dy by dx. So dy by dx was dr by d theta, so that is just expression 2, multiplied by sine theta, plus r cos theta. Well, r is my expression 1, and there's cos theta. So that's going to give me the numerator for what I want. And then the denominator, well, that was dr by d theta, so that's my expression 2 times cos theta, minus r, so that's expression 1, sine theta. And then in order to get my dy by dx, I need to divide 3 by 4. And it gives me sine 2 theta plus 1 cos theta plus 2 sine theta cos 2 theta all over minus sine 2 theta minus 1 sine theta plus 2 cos theta cos 2 theta. Let's have a go at getting that down on paper. So this is the sort of thing that I would write on my paper, copied down from my computer algebra system. So first of all, I would write that dr by d theta in this case is equal to 2 cos 2 theta. And then I would use my formula for dy by dx. So dy by dx is dr by d theta sine theta plus r cos theta all over dr by d theta cos theta minus r sine theta. And so in this case, substituting all of my bits in, I get 2 cos 2 theta sine theta minus sine 2 theta plus 1 cos theta all over 2 cos 2 theta cos theta minus sine 2 theta plus 1 sine theta. And I've just noticed that should have been a plus just there. In this video, you've learned how to find the gradient of a tangent using polar form.